Hello, good morning, everyone.
Good morning, sir.
Morning. Elra Aramidira. Is everyone fine? Doing good? Yes. Great. Okay. By the way, have you guys uh, did the homework from previous unit, that is from real numbers? Have you guys completed the homework? I gave some homework, right? Is there any confusions or doubts from that unit? If there's any, please do ask me. Okay, otherwise, we'll just proceed with a next unit, that is unit second, polynomials. You guys have heard of this term, right? Okay. Have you guys heard of this term, polynomials? Can anyone tell me what do you mean by polynomial? What is this polynomial? Please unmute and do answer me. Otherwise, just put it on the chat box. Yes? No? Okay. You guys have heard of the term monomial, right? What do you mean by monomial? It consists of variable and, yeah, of course, variable and coefficient. What do you mean by monomial? Monomial, yes, a single term. It consists of, like, so it is a monomial, or 8x. So it is a monomial, or 8x square. It is a monomial. But if that, for example, if a equation that is written in this way, so this is a polynomial. You guys have studied regarding this monomial, polynomial, and all in class 9, I guess 9 and 8. They'll have the detailed explanation for all this, introduction for this. And you have also learned about degree, right? Degree of polynomial. What do you mean by degree of polynomial? And can anyone tell me what is the degree of this? What is the degree of this polynomial? What is the degree? Yes. Anyone? Yes, exactly. The degree of this is 1. That means degree of a polynomial means the highest power of x, or that variable. No? For example, here it is x to the power 1, right? Therefore, degree is 1. Suppose if it is 9y square minus 8y plus 2, what is the degree of this? Highest degree of this term, y. Yes, it is 2. It is 2. Similarly, we have some more terms like 17 u to the power 6 minus 3 by 2 u to the power 4 plus 4 u. Then what is the degree? It is the highest one, highest power of u, that is 6. Degree of this is 6. So you guys are familiar with degree of a polynomial, right? Or degree of any equation. And what are the can you give an example for the equation which is not a polynomial, which is not a polynomial? So far these are the polynomial, right? These examples are for polynomials. And if it is 1 by x minus 1, is it a polynomial? Is it a polynomial? 1 upon x minus 1. This is not a polynomial, remember. Also, there's some expressions of the form root x plus 2. This is not a polynomial. Also, 1 by x to the power 6 plus 4x square plus 2. This is also not a polynomial. Remember this. Okay. So far you guys are clear with what is a polynomial and what is degree of polynomial. Then let us discuss about some of different types of polynomials. We have the first type, that is a linear polynomial. Can anyone tell me what is the meaning of this term linear polynomial? Linear. What do you mean by this term linear or linear polynomial? Yes, anyone? No. Okay. This linear. So this actually tells us that the polynomial is of degree 1. So this polynomial is having degree 1. For example, 2x minus 3, 5 u plus 7, and y plus root 6. So all these are examples of linear polynomial. And remember, if I give this expression y square plus 3, remember this is not a linear polynomial because this is having degree of 2, right? You can see these terms, these are having the degree as 1. So these expressions are having degree 1. And similarly, there is second type, that is a quadratic polynomial. Yes. Can anyone tell me what is this quadratic? Yes, exactly. So this is degree 2 polynomial. These polynomials have the degree of 2. For example, 5x square plus 7x minus 2 by 5. Also, square root of 5 z square minus z plus 2. And similarly, I can give I can quote a lot of examples. Okay, so these are the quadratic polynomial of degree 2. Can you guys observe anything, the pattern of this? So this is having a general form of, what is the general form of this quadratic equation? It is ax square plus bx plus c. This is the general form of this, where a, b, c, these are real numbers. And remember, a is not equal to 0 all the time. So this is quadratic polynomial, or a degree 2 polynomial. Then there comes another one. It is the degree 3 polynomial, that is named as cubic polynomial. Cubic polynomial. This is a polynomial of degree 3. For example, 9x cube minus 7x square plus 7, or square root of 18 t cube minus 8t square plus 4. So these are the examples of cubic polynomial having degree 3. And what is its general form? Its general form is ax cube plus bx square plus cx plus d. And here a, b, c, d, these are the real numbers, and a is not equal to 0. Okay, is that clear, everyone? Is that clear? So we have three polynomials. One is of degree 1, that is linear polynomial. Second is the polynomial of degree 2, that is called as quadratic. And polynomial of degree 3, that is called as cubic polynomial. Next is, let us consider an example, that is p of x is equal to x cube minus 3x minus 4. What if I put x is equal to 2? I put the value x, since x is a variable, I put the value, yeah, 2 in the place where there are x. That will be p of 2. That is, how much is the value if I put 2 in the place of x? 8 minus 3 into 2 minus 4. How much is it? Sorry, this is cube, right? Yeah. How much is the value? Okay. Um, Sorry, this is 2. Okay. So this is 2. That means, sorry, this value is 2. Then this becomes uh, how much? 4. So 4 minus 6 minus 4. This gives us like minus 6, if I'm right. Yes. So this will be minus 6. Okay. Similarly, I put the value that is x is equal to 0 in place of ax, that is p of 0, that will be 0 minus 3 into 0 minus 4. So this will be minus 4. Then I can say that if p of x is a polynomial in x, and if k is any real number, then the value obtained by replacing x with a, a digit k or a k, then it is called the value of p of x at k, value of p of x at k, that is denoted by p of k. That means here p of x, we have x square minus 3x minus 4. Then at x is equal to minus 1. That means I write p of minus 1. So what is it? What is the value of this? If I insert minus 1 here, p of minus 1, this will be 1 minus 1 plus 3 minus 4. It will be how much? What is the answer? It's 0, right? Yes, it is 0. And you can see if I insert minus 1 here, the answer will be 0. But what is in the previous case, I just replaced x with 2. That means I get the answer as minus 6. Also, if I insert 0 in place of x, that gives me minus 4. But if I insert x, that is at x is equal to minus 1, so this equation or this expression, that gives me the answer 0. Similarly, at p of 4, so I insert 4 in the place of x, that is 16 minus 12 minus 4. What is the answer? Again, it is 0. I can say these terms 1 minus 1 and 4 are the zeros of this quadratic polynomial. Minus 1 and 4, these are the zeros of the polynomial. Since when I use this minus 1 and 4 at x is equal to minus 1 and 4, these expression gives me the answer or the value as 0. Remember, so if I say zeros of a polynomial, means the terms, the digit that gives me the answer 0 when I substitute that value in that expression. So generally, a real number k is said to be 0 of the polynomial p of x if p of k is 0. A real number k is said to be 0 of a polynomial P of x if P of k is equal to 0. Remember this. Okay, let us see some examples. Find zeros of linear polynomial. That is the first one. P of x is equal to 2x plus 3, and P of k is equal to 0. Then I can write, since it is a linear polynomial, I can write this as 0, and 2k plus 3 is equal to 0. Just rearranging the terms, you will get minus 3 by 2. Right? And generally, if k is 0 of p of x of the form ax plus b, then pk is equal to ak plus b, which is equal to 0, or I can write k is minus b by a. So this is the general form. You can see here, this is b, right? So this term is b, and this is a here, right? So that gives me minus 3 by 2. So general form of a linear expression or linear polynomial. So to find 0 of that, now that 0 is having this form, k is equal to minus b by a. Also, the general form 0 of linear polynomial having, this is the general form of linear polynomial, right? So this is minus b by a, where minus of constant term divided by coefficient of x. So what is here, this is minus 3 by 2. Is this 3 is, look at this, that is the constant term, right? This is the constant term. Then 2, this is the coefficient of so okay. If I want to find the zero of this, can anyone tell me what is the zero of this expression? How to find the zero of this expression? 3 by 7. So P of k is equal to 7k minus 3 is equal to 0. That is k is equal to 3 by 7. So at k is equal to 3 by 7, it is, the expression becomes equal to 0. If you just insert 3 by 7 here in this expression, x is equal to 3 by 7, its value will be 0. You can see here 7 into 3 by 7 minus 3. So it will be 0. That becomes equal to 0. So 0 of this linear polynomial, this is how you find 0 of a linear polynomial. And also you can see here this 3 is a constant term. This is a constant term, and 7, this is a coefficient of x. Is that clear to everyone? I need everyone's answer. Okay. Okay. Next is geometrical meaning of zeros of the polynomial. How we can geometrical interpret this geometrical meaning of zeros of a polynomial. That is, we can interpret using the graph. Okay, let us consider a linear polynomial. Linear polynomial is of the form ax plus b, where a is not equal to 0. And remember this, in a linear polynomial, always when you plot, when you insert different values here and you plot the value, you will get a straight line. I hope you guys have did all this using a linear polynomial in your previous classes. Yes. Okay. For example, if I take the value y is equal to 2x plus 3, that means just draw the table for this x. Y is equal to 2x plus 3, and you will see for x is equal to minus 2, it is minus 1, and for x is equal to 2, it is 7. Then if I plot a graph, then it will be a straight line, since we have at minus 2, it is 1 2 3 minus 1 minus 2 minus 3. Okay, at minus 2, its value at x is equal to minus 2, its value is minus 1. This is y. A second. Y, this is x. Minus 2 minus 1. This is minus 1. So at this point, and one more at plus 2, it is 7. Yes, around this. Okay, if I plot the graph, it will be like this. Correct? Then you can see intersection. This line is intersecting at certain points of x-axis, that is at this point. This is 1.5, right? So this I can write as minus 3 by 2 comma 0. Correct? Along x-axis it is minus 3 by 2, and along y-axis it is not intersecting at all, so 0, right? So it intersects at minus 3 by 2 comma 0. Also this line is y is equal to 2x plus 3. This point is 2 comma 7, and this point is minus 2 comma minus 1. So this is graphically, but if I use that equation, and if I try to find the zero of that using traditional method, that is the same value that we have got, we have obtained here. Look at this, the value of this. So 2x plus 3, that is having 0 at minus 3 by 2. That means if I plot a line using that equation, it will intersect exactly at minus 3 by 2 of x-axis. So from this graph also I can say 0 of 2x plus 3 is minus 3 by 2. So 2x plus 3 is the x coordinate of the point where graph of y is equal to x plus 3 intersects the x axis. Is that clear, everyone? So this is the geometrical interpretation of linear polynomial. Similarly, if I take the example of quadratic polynomial, meaning of a quadratic polynomial. And here you can observe in a linear polynomial, there is only one zero. That means it is intersecting at only one point of x-axis. Remember, a linear polynomial will have only one zero. But in case of quadratic polynomial, let us see. So far you guys understood this, right? No doubt. Okay. If it is case of a quadratic polynomial, let me take an example of x square minus 3x minus 4. I can write this as x square minus 3x minus 4. And if I plot the table like this, x y is equal to x square minus 3x minus 4, and for different values like minus 2, minus 1, 0, 1, 2, 3, 4, 5, and you will get like 6, 0, minus 4, minus 6, minus 6, minus 4, 0, 6. Okay, and if I plot a graph then it will be of this type, and it will intersect at -1 comma 0. This is y, and this is x. This point is -2 comma 6, and this is, I'm just roughly drawing this, okay. And this point is 4 comma 0. This is 5 comma 6, and this is 0 comma -4. This point is 3 comma -4, also 2 comma -6, and this is 1 comma -6. So in this, what you observe here, how many zeros, can anyone tell me? How many zeros does this graph is having? Zeros means the point at which that line that intersects the x-axis. So how many zeros does this graph is having? Yes, it is 2 zeros. This is the first one and this is the second one. Since that line is intersecting the x-axis at those 2 points. And remember, we are considering only the points where the x-axis intersecting, not the y-axis. So if it is intersecting the y-axis, we are not considering that point. So only the point with which intersects the x-axis. So zeros of this are -1 and 4. So here you can see it is at 4 and this is at -1. Also, when you're taking a quadratic equation, you get either this kind of graph. This is, this kind of graph are nothing but these are called as parabola. Remember this word, parabola. So this is upward parabola, and if it is like this, if we obtain this kind of graph, then it is downward parabola. Suppose consider a case one in which the graph cuts the x-axis at two distinct points, A and A prime. So graph cuts at two distinct points, that is A and A prime. Such cases will be like this, or the one which I draw previously. So this cuts at this point A, and this is A prime. Similarly, A and A prime. This is a case one. So if you are drawing a graph of a quadratic polynomial, then you will get, in first case you may get this kind of graph. Otherwise, in case 2, you may get a graph which cuts the x-axis at only one point, at only A, or like this, at only point A. That means how many zeros in this graph? How many zeros in this graph? Yes. How many zeros? How many intersections you see? So the x-axis. Only one, right? This is only a 1 point. So zeros, only 1 0. Also here, so it is one, only 1 point. It is at only 1 point that graph is intersecting the x-axis. Also, there is one more case of a parabola in which the graph will be like this or like this. So some quadratic polynomial that gives the graph of this kind. So how many zeros here? How many zeros in this type of graph? Yes, it is no, it is no zero. There is no zeros because the graph is not intersecting at all. So I can conclude that polynomial of degree 2 can have can have at most two zeros. So it may have zero zeros or one zeros or at the max two zeros. And also, what if I consider a cubic polynomial? Here is one example. I take x cubed minus 4x. Then I take the table of this x and y. At x is equal to minus 2, this will be 0, and x equal to minus 1, it is 3. At x equal to 0, it will be 0, and at x equal to 1, it is minus 3, and at x equal to 2, it is 0. And if I plot a graph of this, then it will give me this kind of graph. Okay, this is at minus 2 comma 0, this is minus 1 comma 3, and 1 comma minus 3, and this is 2 comma 0. This is y-axis and this is x-axis. And can anyone tell me how many zeros in this graph? How many zeros? I need everyone's answer. Only Aditya and Namrata have answered. Just look at the points where this graph or that line that intersects the x-axis. How many points? I'll wait for everyone's answer. Yes. I'm audible, right? Yes. Then give me the answer. How many zeros in this graph? How many zeros in this graph? Because I didn't get everyone's answer. Only two have answered me. Yes. I'll not proceed unless I get everyone's answer. Only three have answered me. Okay. And rest of I got the answer from Aditya and Namrata and Noor Sadaf and Prajul, Smriti, Pavana. Okay. And other people, have you guys understood or not? I didn't get answer from Abhiram, also Bhumika, then Hitaishi, then yeah, yes, okay, fine. Okay, so you can see here this graph or this line is intersecting the x-axis at how many points? At this point. This is first point, okay. And also you can see here intersecting at one more point, second, and here one more. So you can see it is intersecting at 3 points. So zeros of this graph are zeros at 3 points, that is at -2, and this is 0. Okay, this is almost 0. This is 0 and this is 2. One more point at 2. So this is intersecting, this graph is intersecting the x-axis at 3 points. And let me quote some more examples, that is of cubic polynomial x is equal to y is equal to x cube. For this, the graph will be of this type. Okay, the graph will be almost of this kind. This is -2 comma 8, this is 1 comma 1, and here it is -1 comma 1. So how many zeros here? zeros. Here it is only 1 0 because it intersects at only one point. Only one. Also, if I consider one more graph, that is y is equal to x cube minus x square, on plotting, you will get a kind of graph which is in this way. Okay, it can be plotted like this. So this point is 2 comma 4, and this point is 1 comma, this point is 1 comma 0. Sorry, this is 1 comma 0. uh, Something, there is a mistake here. Yeah, just leave it. Okay, yeah, just look at the graph here. It is intersecting at how many points? How many points it is this graph is intersecting? Yes, this graph is intersecting at 2 points. That is, one is at here, one more is here. So number of zeros intersecting at 2 points. So zeros will be two number of zeros. So hope clear, this is clear for everyone. So in general, I can say a given polynomial p of x of degree n, then y is equal to p of x intersects the x axis at most at n points, or a polynomial p of x of degree n has at most n zeros. Okay, if I consider a cubic polynomial, then how many zeros it can have? A cubic polynomial that can have at most 3 zeros, and a quadratic that can have at most 2 zeros. Also a linear can have at most 1 zero. Is that clear for everyone? Got it? And yeah, here is one example. This graph is intersecting in this way. So how many zeros? How many zeros in this graph? Yes, it is only 1 0 because it is intersecting the x-axis at only one point. This is x-axis, this is y-axis. So 1 0. Also, what type of polynomial is this? Linear, quadratic, or cubic polynomial? What kind of polynomial is this? Yes, it is a linear type. It is a linear polynomial. Good. And one more example. This is the graph of this kind. This is y, this is x. How many zeros? Yes, it is 4. 1, 2, 3, and 4. And this is a polynomial having degree 4, right? Is a polynomial of degree 4. And let me do some numericals from this exercise 2.1. I'll just do only 1 or 2, okay? And rest is homework for you. Okay, how many zeros here? This is the fourth one. How many zeros? Yes, zeros only 2. And what type of polynomial is this? What type of polynomial? Yes, it is quadratic. Since you are getting a parabola, this is a parabola, right? The upward parabola. Good. And one more. This is okay. How many zeros? Yes, this is having 3 zeros. Also, this is a cubic polynomial. And this is a problem number 5. Okay, fifth one. Okay, and rest is for you. Rest of the numericals, that is the first one, second one, and third one, and fourth one I did right now, right? And the fifth one. So these are all homeworks. Okay, please do the homework and let me know if you face any difficulties. And in the next class, we'll discuss about relationship between zeros and coefficients of a polynomial. Okay, we'll discuss about the relationship between zeros and coefficients of a polynomial. So far, in today's class, what have we discussed? Can anyone summarize today's class? Anyone? So today we understood about how we can find zero of a polynomial. Zero is a point at which that graph intersects the x-axis. That intersects the x-axis, right? That point is known as zero of that polynomial. Also, we understood about linear, and linear polynomial can have at most one zero, and quadratic, this can have at most two zeros, and cubic, this can have at most three zeros. This cubic polynomial can also have two zeros or one zeros as well. Also, this quadratic polynomial can have 0, 1, or 2, this many number of polynomials. And zero of a linear polynomial, that is having general form ax plus b, that is minus b by a, minus of constant term, then this is coefficient of x. Okay, we have discussed about finding zero of polynomials. Yes, good. Any doubts? Another doubt, Idea?